All right, welcome to the circuit section. We're going to draw a simple circuit with a battery and a resistor showing an ammeter and a voltmeter connected correctly. Oh, that's a pretty weak excuse for a battery, but you'll give me a break on that, right? And a little ugly. This one here is the ammeter, and to connect, so the ammeter goes in series right in the circuit. You have to open up the circuit to put the ammeter in. And the voltmeter goes in parallel with wherever you're trying to measure the voltage or the potential difference change. And so if I wanted to measure it in that resistor, I would hook it on each end of the resistor, and it would be like its own little separate section of the circuit. All right, circuits in Japan use 240 volts. It uses 2.5 amps. How much resistance does it have? The basic equation for all of these is going to be I is V over R. And so if I'm looking for R, I get V divided by I. In this case, 240 volts divided by 2.5 amps. And that's going to give 96 ohms. Circuits in Europe use 220 volts. How much power would a 3-amp device use? So power is I times V is one of the options, and I have a current of 3 amps and a voltage of 220 volts. And when I multiply those together, I get 660 watts of power. Circuits in the U.S. use 120 volts. If the current is 2 amps, what's the resistance? We're going to go back up to problem number 3 and use the V divided by I from the Ohm's law equation. 120 volts divided by 2 amps should give me 60 ohms of resistance. All right. Number 6, for which type of circuit, series or parallel, is the current always constant? Series, only one path for those electrons. All the electrons have to go through all the parts, and current just measures charge per second. Which type of circuit, the voltage drop always equal. In a parallel circuit, the voltage drop is equal across all the resistors. Here we go for number 8, 2, 4, and 6 ohm resistors with a 12-volt battery. So the equivalent resistance in series is just adding up the resistors. So 2 plus 4 plus 6 gives me 12 ohms of equivalent resistance. The current through each resistor, that's the same as the total current. So I can take my 12 volts of battery divided by my 12 ohms of resistance. I is V over R. And I get 1 amp of current. The voltage across each resistor, here's where we want to be figuring out for each one. So the 2 ohm resistor, when I rearrange, I equals V over R, solving for V equals I times R. So I've got 1 amp times my 2 ohms, gives me 2 volts at the 2 ohm resistor. The voltage at the 4 ohm resistor is going to be 1 times 4, or 4 volts. And the voltage at the 6 ohm resistor, 1 amp times 6 ohms, gives me 6 volts. The power for each resistor, let's change colors. All right, power is I times V, and the current is not changing, it's 1, so I get 2 watts at the 2 ohm resistor, 4 watts at the 4 ohm resistor, and 6 watts at the 6 ohm resistor. And the last section here, what happens to the power drawn by the resistors if a fourth is added in a series? If I add another resistor, the equivalent resistance increases, which means the current decreases because I is V divided by R. And if the current goes down, the power also decreases. All right, here we are with the parallel circuits. We need the equivalent resistance of the entire circuit. So the equivalent resistance in this case, we sum up 1 over each of the resistors, and they are all 8 ohms. And we take the inverse of the answer. And I get an answer of 2.67 ohms. The shortcut to this, when all of the resistors are the same, and only when all the resistors are the same, is put the size of the resistor on the top, the number of them on the bottom, and you do the math and you still get 2.67 ohms. Current through each resistor. So I know that my voltage is going to be the same for each of these, which is 12 volts. So when I is V over R, I get 12, and each resistor is 8 ohms. Works out to be 1.5 amps of current. The voltage for each resistor, this is the secret to parallel circuits. They all use all 12 volts. So the power for each resistor, since these are all the same, power I can use I times V, where I know I is 1.5 amps. The voltage is 12 volts. And when I do the math, that's going to equal 18 watts of power. What happens to the power if a 4th resistor is added in parallel? Then the equivalent resistance decreases, which means my current increases. And if current goes up, power has to go up also. Circuit A has 2 resistors in series. Circuit B has 3 in series. The resistors are all equal, which means B has a bigger resistance, A has a smaller resistance. Which one gets the most current? I is V over R, so the current is highest in A. And the most power? Well, P is I times V, so power is also highest in A. Circuit A has 2 resistors connected in parallel, 1 on each branch. Circuit B has 3 in parallel. The resistors are all equal. In this case, adding resistors lowers the total or the equivalent resistance, which means that the current goes up. So B carries the most current and the most power in a parallel circuit. In a circuit, the fuse is designed to limit the current. That's the part that's so dangerous for people, and so that's what the fuses are for. Most common voltage in the U.S., 120 volts. Big things like air conditioners and stoves can pull 240. To ensure that the same voltage is applied to each socket, they wire them in parallel. And then the next section will be magnetism, which I will do in another section of slide. See you later.